This is the notes for advanced algebra, topic 8, section 2. In the first section of this topic, we learned about basically the vocabulary of quadratic functions, and then in the next two sections, we're going to look at the quadratic functions in what we call vertex or graphing form, and what we call standard form in the next section. So first, vertex or graphing form. The reason we call it vertex or graphing form is because I can look at this equation and I can tell you that the vertex is the ordered pair HK. Okay, so if I had f of x equals 2 times the quantity x plus 1 squared minus 3, the vertex of that would be -1, -3. I take the opposite of what's in the parentheses and the same as what's out here for the y value. I can also tell you that this parabola opens up because the a, the coefficient, if it's greater than 0 means positive, the parabola opens up. If it's less than 0 means negative, the parabola opens down. And as I said, the vertex is HK. The axis of symmetry is a vertical line that goes through the vertex. And so it is an equation of a line. The axis of symmetry for this parabola that I have up here would be x equals -1. And it has to be x equals -1. If you just put -1, it's incorrect, because it's a line and I'm writing the equation of a line. An equation has an equal sign. And it's a vertical line, so it's x equals -1. Okay. And then we can look at this. So we have, for an example here, x minus 1, the quantity x minus 1 squared minus 1. The vertex is going to be the opposite of what's in there, which is going to be +1. And the same of what's out here, so that's going to be -1. And the axis of symmetry is x equals the x coordinate of that vertex. And then we'll talk about the domain and range here in a second. So to graph this, I'm going to graph the point 1, -1. And the axis of symmetry is this vertical line going through there. And its equation is x equals 1. It goes this way too. And then for when I'm in graphing form, what I'm going to do to find other points, I'll make a table. And I'll plug in a value for x, and I'll get a value for y. So what's right next to my vertex here? What's the point right next to it? And the point right next to it is either 2 or 0. And take your preference, plug in either one. I'm going to plug in 2. So I'm going to have 2 minus 1 squared minus 1. 2 minus 1 is 1. Squared is 1. Minus 1 is 0. So a point on my parabola is the point 2, 0. And then this axis of symmetry tells me that if there's a point here, there has to be a point right here. Okay. And then I need another point. So what's right next to the point I just found? Or what's right next to 2? 3. I'm going to take 3 minus 1, square it, subtract 1. Let's see, 3 minus 1 is 2. 2 squared is 4. 4 minus 1 is 3. So I plot the point 3, 3. Then I use my axis of symmetry, and I get this point over here. And that's enough points to draw my parabola. These do not make a V. This is a curve at the bottom down here. Okay, that's imperative. And that's what the graph looks like. So the domain, there's really not anything I can't plug in for the domain. The domain is all real numbers. Okay. The range, that's the values for y. And obviously my y values are from here upward, right? Because my parabola opens up. This y value down here is -1. So for the domain, for the range, we say y is greater than or equal to -1. And that's everything we need to know for this section, basically. Okay. Here we have another example. We look at it and we find the vertex first. The vertex is the opposite of what this is. So the opposite of -2 would be +2. Then I take the same of what's out here. So the vertex is at 2, 1. The axis of symmetry would be x equals 2. And at this point, 2, 1 is here. And the axis of symmetry is this vertical line, right? And the equation of that vertical line is x equals 2. Okay. Now I need some other points to plot. So I'm going to plug in, and I'm not going to show my work here. What's right next to 2? 3. So I'm going to plug in 3. Well, 3 minus 2 is 1. I square it and I get 1. I multiply it by -3 and I get -3. And -3 plus 1 is -2. So 3, -2 is a point on that graph. Then using my axis of symmetry, there has to be a point over here. The axis of symmetry is like if I were to fold this graph on its axis of symmetry, this point would land on this point. Okay, some teachers describe it as a mirror. If this is my mirror, then here's the point, this is its reflection, okay, on the other side. And that's true when I have an axis of symmetry. I don't know that we're going to be able to plug in 4 because I think it's going to be down here outside of my graph, but we'll try. Let's see. 4 minus 2 is 2, and 2 squared is 4, times -3 is -12, and -12 plus 1 is -11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's somewhere down here. Okay, you can't see, but it's, if I keep counting and go down, it's somewhere down here. So I'm not going to worry about it. I have enough points because I know what a parabola is supposed to look like. It's curved. Oops, I missed. Oh, I missed that one too. That just calls for enlarging those points. There we go. Looks good now. And my domain is all real numbers. And my range, this time because my parabola opens down, my range is from this point down, or y is less than or equal to 1. All right, moving right along. Vertex here, the opposite of what's in here. So this is +1, its opposite would be -1. And same of what's out here, 4. So the vertex is -1, 4. Axis of symmetry, x equals -1. So -1, 1, 2, 3, 4. And this graph is going to open up. And I don't know, we may have to do some adjusting here. Let's see, what's right next to that is 0. So I plug in 0, I get 0 plus 1 is 1, squared is 1, plus 4 is 5. I can graph that. 0, 5 would be right here. And then my axis of symmetry would put another point over here. Again, my axis of symmetry is this vertical line. and it has the equation x equals -1. And I really think if I plug in 1, 1 plus 1 is 2, 2 squared is 4, plus 4 is 8, 2, 3, 4, 5, 6, 7. So it would be up here just slightly. We can kind of make that fit in there. So then my axis of symmetry would put another one over here. And there we go. Domain is all real numbers. That's our symbol for all real numbers. And the range, the vertex here is at 1, 4. So y is greater than or equal to 4. This last example on here, I'm going to reserve for class. We're already at 11 minutes, and so I'm going to quit there. So